The James Webb Space Telescope has been in the news since it was launched on Christmas Day 2021. The superstar telescope has since unfolded the universe in a way no one expected.
And 100 million times the mass of the Sun, which is absolutely unbelievable when you consider it's comparable to the total mass of all the stars in its host galaxy.
These galaxies are well formed and contain more stars than today's galaxies like our Milky Way. These galaxies should not exist as they toy with our model of cosmology. To make matters more uncomfortable for scientists, researchers from the University of Minnesota have discovered that one of these galaxies is so bizarre that we might have to go back to the drawing board.
The telescope really surprised everyone by revealing some incredible details about this nebula.
Represents a quantum leap
the ring
forward
itself
in
is
our
composed of
ability to
about
explore the
20,000
cosmos
clumps
with
of
its
molecular
advanced
hydrogen,
instrumentation
and the
and
inner region
unparalleled
ever seen in
sensitivity.
X-rays in a galaxy called
promises to
UHC-1.
revolutionize our
The impressive
understanding
part?
of the universe,
UHC-1 is
particularly in the realm of early
13.2 billion
universe
light-years
studies.
from Earth.
One of JWST's most remarkable features is its ability to collect approximately 10 times as much light as its predecessor, the Hubble Space Telescope. This significant increase in light-gathering power enables JWST to peer deeper into the cosmos, unveiling celestial phenomena that were previously beyond the reach of observation. By
Hydrogen.
capturing a wealth of photons emanating
11.
from distant galaxies
Circles of
and
the Ring
cosmic
Nebula.
structures, JWST
There's also the Ring
opens a
Nebula,
new window
known
of
as
exploration,
M57,
offering
in the
astronomers
constellation Lyra.
unprecedented insights into the universe's origin and evolution. JWST's enhanced sensitivity at redder, longer wavelengths in the infrared spectrum provides astronomers with a unique tool for studying the early universe. Unlike visible light, which is often obscured by cosmic dust and gas, infrared radiation can penetrate these dense
Young
clouds,
stars,
revealing
many of
hidden
them similar in
celestial
mass to
treasures
our
that would
Sun.
otherwise remain
If it weren't
invisible.
for James Webb,
This
it would be like
capability
looking at a
is
black
particularly
picture.
valuable for observing
But what
distant
impresses me the
galaxies and
most
ancient
is that the
stars
and
whose
guess
light
what?
has been stretched to
This
longer
line of
wavelengths
galaxies
due
could
to the
grow to
universe's
become a massive
expansion.
cluster of
By harnessing
galaxies,
the power of
like the
infrared
Coma
astronomy,
cluster we know in our cosmic
JWST
neighborhood.
allows scientists
4.
to peer back in time to the cosmic dawn, the epoch when the first stars and galaxies emerged from the primordial soup of the early universe. This cosmic dawn holds the key to unlocking
This on Earth.
fundamental mysteries
Only
about
living
the
organisms.
universe's formative
I'm sure
years,
you're smart enough to
including
connect the dots here.
processes of galaxy formation,
3.
star birth,
Origins of the
and
cosmic web.
reionization.
Astronomers
One of
using NASA's
JWST's primary goals is to study the epoch of reionization, a pivotal phase in the universe's history when the neutral hydrogen gas that pervaded the cosmos was ionized by the intense ultraviolet
Specifically, there's the
radiation
Rho
emitted by
Ophiuchi
early
complex,
stars and
which
galaxies.
is only 390
By
light
observing
years from
distant
us.
galaxies and
The
quasars
telescope
during
captured
this
an
epoch,
explosion frozen in
JWST
time,
can shed
with
light
about
on the
50
timing, extent, and mechanisms of cosmic reionization, providing crucial insights into the transition from the cosmic dark ages to the luminous universe we observe today. JWST's infrared capabilities enable it to peer through the veil of cosmic dust and gas, unveiling the hidden processes of star formation and galaxy evolution.
star
By
formation.
studying the infrared
But stars
emission
form
from
in dense
dusty
clouds of gas
star-forming
and dust,
regions
right?
and protogalactic
Well,
disks,
usually the
astronomers
dust
can
blocks
trace
most
the
of the
birth
visible light.
stars and the assembly of galaxies across cosmic time, unraveling the intricate tapestry of cosmic evolution. JWST promises to revolutionize our understanding of exoplanets, worlds orbiting distant stars beyond our solar system. By detecting the faint infrared signatures of exoplanet atmospheres, JWST can
Very
analyze
large
their
array
composition,
to pick up radio
temperature,
waves coming
and
from one of these
potential
jumbo systems
habitability,
called Jumbo
paving the way for the
24.
search for life
The
beyond
radio
Earth.
signals are
The
constant and
scientific
come from
potential
both
of
parts of the
JWST
binary
is vast
atmosphere,
and
and more
multifaceted,
recently,
spanning a
the
wide
James Webb
range of
telescope found
astronomical
carbon-containing
disciplines, from the
molecules
study of
like
distant
methane and
galaxies
carbon
quasars
dioxide.
to the exploration
So yes,
of nearby
K218b
exoplanets
might have a
and
hydrogen.
systems. Its unprecedented sensitivity, combined with its ability to observe in the infrared, positions JWST at the forefront of modern astronomy, poised to uncover new insights into the nature of the universe and our place within it. As astronomers prepare to embark on a new era of discovery with JWST, they stand on the threshold of a profound journey,
and they are unlike
one
anything
that
we've seen
promises to
before.
illuminate the darkest
Each has two
corners of the
parts,
cosmos
like a
and
double
reveal
planet
the secrets of the
situation,
universe's
with masses
origins.
ranging from
With each
0.6 to
observation and
14 times
discovery,
that of dark after all.
JWST brings us one step closer
2.
to unlocking the
New
mystery
discoveries
of the
in
universe
exoplanet
and expanding
molecules.
the horizons of human knowledge.
For some
But to
reason,
understand the
astronomers
early
have been
universe,
obsessed with
we
finding
need
an
to go back in time to a point where time and space did not exist. According to the theory of cosmic inflation, the universe was born with a Big Bang as an unimaginably hot, dense point. When the universe was just 1/100 of a billionth of a trillionth of a trillionth of a second in age, It experienced an incredible burst of expansion known as inflation,
9.
in which space itself
Jumbos in
expanded
space.
faster than the speed of light. During
I'm sure
this
you've heard of
period,
jumbos,
the
not the
universe doubled in
sandwich,
size
but the
at
Jupiter
least
mass
20
binary
times,
objects.
going from
They are
subatomic
these
size
wild
to
a
golf
few
ball
hundred
sized
million
almost
years after the Big
instantaneously.
Bang.
After that,
One of these
the growth of the
galaxies is a
universe
trillion
continued,
times
but at
more
a
massive
slower
than our
rate.
Sun,
As
and
space
10 times
expanded,
larger than the Milky
universe
Way.
cooled, and matter formed. Only 1 second after the Big Bang, the universe was filled with neutrons, protons, electrons, anti-electrons, photons, and neutrinos. However, for the first 380,000 years or so, the universe was essentially too hot for light to shine. But 380,000 years
Astronomers
later,
scratching their
matter
heads.
began to cool
I'm
enough
talking
for
about some
atoms to
needle-shaped
form.
structures in
After this
ionized
point,
hydrogen
the
that seem
universe
to
was
defy
plunged
all
into
known
darkness
patterns,
since no
and they are much
stars or
larger
any
than the
other bright
scientific
objects had
community.
formed yet.
These 6 points were
Fast
so
forward
red
to
that they must have
400
formed just a
million
few
years
hundred
after the
million
Big
years
Bang,
after the Big
and we
Bang.
can see the universe
And contrary to
beginning
what
come out of its
scientists
dark
previously
ages.
believed,
This
these structures
period
couldn't
in
have
the
formed
universe's evolution is called the Age of Reionization. During this phase, which lasted for more than 500 million years, the first stars started to appear, and galaxy formation began, building up in the first billion years after the Big Bang. Galaxies sort of reached adolescence. However, the James Webb Space Telescope has found not
Thanks
one
to
but
the
6
James Webb
galaxies that were
Telescope.
fully formed
The
only
telescope's
500 million
near-infrared
years
camera
after the
recently
Big Bang,
captured the
and
most
that is a
detailed
problem.
image of the
Using
Sagittarius
first of
A
their kind
region,
observations
which is
from the
about
James Webb
1,000 light
Space
years from.
Telescope, a University of Minnesota team looked more than 13 billion years into the past to discover a unique, minuscule galaxy that generated new stars at an extremely high rate for its size. The galaxy is one of the smallest ever discovered at this distance and could help astronomers learn more about galaxies that were present shortly after the universe came into existence.
In the long run,
galaxy's volume
this discovery
is
has
roughly a
shaken
millionth of the
everyone
Milky
because the
Way's,
universe did
but
not
we can
start as
see
we
that it's
thought,
still forming
and the
same
dark
number
ages of the
stars
universe
each
may
year.
not have been so
The
dark after
galaxies
all.
that existed when the universe was in its infancy are very different from what we see in the nearby universe now. Scientists studying these galaxies could help us figure out how and when these first stars and galaxies emerged from within the universe's dark ages. Until then, it remains a mystery as to how the universe came into being. As days pass, more results of observations from JWST are revealing that the universe, especially at its early stage, was stranger than we imagine. Not only has Webb discovered
And among
these
many
early
candidates,
galaxies,
there is
but it has also
K2ATB,
now
one
found
that might
a black
harbor
hole
life.
that is almost
Why?
as old as the universe.
Well, for one,
Scientists
they
have
found water
discovered what
vapor
they
in its
believe to be
atmosphere,
the oldest
and
known black hole in the universe, owing to the telescope's ultra-powerful sensors that captured this elusive entity. This supermassive black hole, which dwarfs our Sun by a staggering 10 million times, existed at the center of a galaxy 570 million years after the universe's inception, a time so remote it's difficult to fathom. To put it in perspective,
and an ocean of water.
the universe itself
Perfect conditions
is
for
estimated
life,
to be
right?
13.7 billion
Wait
years
until I
old.
tell you that dimethyl
Observations
sulfide was also
collected through the
detected.
James Webb Space
And guess who
Telescope
produces this
have
on
revealed
Earth?
an active supermassive black hole, 10 million times the mass of the Sun, one that is actively growing as it slurps up matter from the space around it. At just 57 million years after the Big Bang, this is the earliest growing supermassive black hole detected yet, although scientists are hoping it won't remain the record holder for long. The black hole was found inside one of the earliest galaxies ever detected, previously known as EGSY-8, though since renamed CN19. Its discovery could help with one of the biggest head-scratchers of the early universe: how the black holes in the cosmic dawn grew to such large sizes in such a short amount of time. The statement "we found the most distant active galactic
also spotted
nucleus,
10 galaxies
AGN,
arranged like a
and the
string
most
just
distant,
830
earliest black
million
hole
years
we've ever
after the Big
found
Bang.
encapsulates a monumental
It's like finding a
breakthrough in
childhood
our
photo of this
understanding of the
universe.
cosmos.
But why?
It signifies the discovery of CN19, a galaxy housing not only an active AGN but also an exceptionally ancient black hole. This discovery stands as a testament to the remarkable capabilities of modern astronomical instruments and the relentless pursuit of knowledge by scientists. The journey to uncovering CN19 began with a meticulous examination of the universe's infancy. Scientists, armed with cutting-edge technology and profound curiosity about the early cosmos,
Moreover,
embarked on a quest
this structure
to
is
study
about
star
3
formation
million
in
light
its
years
earliest
long
stages.
and anchored by a
Their
super bright
target,
quasar,
CN19,
which is a galaxy with a
celestial
giant black
entity
hole
shrouded
at its
in the
center.
mists of time,
And guess
yet
what?
glowing with the promise of unveiling secrets hidden within the cosmic dawn. Star formation, a fundamental process in the evolution of galaxies, emits a distinctive signal known as Lyman alpha emission. This signature, originating from the ionisation of neutral hydrogen by nascent stars, serves as a beacon, illuminating the darkness of the early universe and beckoning astronomers to peer deeper to unravel the mysteries of cosmic genesis concealed within the depths of space and time. As scientists turned their gaze towards
CN19, black holes. You probably know that black holes grow in size by consuming stars and clouds of gas and dust that pass by. Thanks to James Webb, scientists have now captured supermassive
stirring from eons of slumber to cast its luminous gaze upon the cosmos. This discovery defied conventional wisdom, challenging our understanding of the early universe's dynamics and raising profound questions about the interplay between black holes and galactic evolution. The coexistence of an AGN and a black hole within CN19 offered a tantalizing glimpse into the cosmic drama unfolding in the ancient epochs of the universe. It hinted at a symbiotic relationship between black holes and their host
X-rays
galaxies,
in a galaxy called UHZ-1.
Cosmic entities
the impressive
played a
part?
far more significant
UHZ-1 is 13.2 billion light-years from Earth,
Moreover,
meaning
the
we are
discovery
seeing
of this black hole at such a staggering distance, merely 570 million years after the Big Bang, threw into sharp relief the profound mysteries of the cosmic dawn. How could a black hole, an entity requiring substantial time to grow, attain such colossal proportions so early in the universe's history? The answer to this puzzle eluded scientists, spurring them to re-evaluate existing models of black hole formation and growth. Perhaps, as some theorize, the seeds of black holes were sown in the very
massive
fabric
galaxies
of the
in a
early
seemingly
universe,
ordinary
sprouting
backdrop.
rapidly in the fertile
6 bright
cosmic
red points of
environment.
light were discovered by the James Webb telescope.
There might have been mechanisms at play, yet to be uncovered, that accelerated the growth of these cosmic behemoths, propelling them to prominence in record time. The discovery of CN19 and its ancient black hole marked the beginning of a new chapter in our understanding of the cosmos. It compelled scientists to look beyond the familiar and consider new possibilities in the realms of cosmic evolution and black hole physics. As the AGN within CN19 continues to radiate its ancient light across the expanse of the universe,
points were so red that they must have formed just a few hundred million years after the Big Bang. And contrary to what scientists previously believed, these structures couldn't have formed at that time.
We know it. JWST is an infrared powerhouse designed to peer deep into the universe and its past, and it's living up to its name.